Okay, so here are the answers to the first three examples for the decomposition reactions. So this is slide 40 in your digital notebook. Again, the first one has been done for you, but I'm gonna kind of talk through it just so you can understand and see where we got those answers. So decomposition is now the opposite. We'd have one compound that is breaking up into two individual elements. So anytime you have a compound, which is one thing, so aluminum oxide does not have a plus sign between the two words, so that would be a compound. So anytime you have a compound, you have to balance out the positive and negative charges if it's ionic, which usually they are. So if you look on your periodic table of ions, aluminum is +3, oxide is -2. So 2 and 3 both multiply into 6. So in order for these charges to be equal and opposite, we would need 2 aluminums and 3 oxygens. So remember, when you're balancing the charges, that's when you can add those subscripts. All right, aluminum oxide forms aluminum. Aluminum is just Al by itself, but oxygen, if you remember from down here, is diatomic. So that's why oxygen has to be O2. So don't forget to look at your list of diatomic elements at the bottom. All right, so this is my skeleton equation. Now I have to add my coefficients to make a balanced equation, to balance out the number of atoms. All right, so I'm gonna make my inventory over here. And again, you don't have to do this, but it's sometimes helpful. Aluminum, you have 2 on the reactant side. We have 3 oxygens on the reactant side, 1 aluminum on the product side, and 2 oxygens on the product side. So aluminum is not balanced right away. We have 2 aluminums on the product side, or the reactant side, so we need to put a 2 in front of aluminum as a product. Now aluminums are good, but oxygens are not. So we have 3 and 2 for oxygens. 3 and 2 both multiply into 6. So in front of the reactant, if we put a 2 here, we can multiply the 2 by the 3 for oxygen to give us a total of 6, but then we also have to change the number of aluminums. So that changes our aluminums to 4, and it changes our oxygens to 6. So now, on the product side, I have to fix aluminum, so I have to completely erase that initial coefficient that I had and change it. So I have 4 aluminums on the reactant side, which means I'm going to need 4 product atoms for aluminum. And then if I look at my inventory, I have 6 oxygens on the reactant side, so I need a total of 6 on the product side. So if I put a 3 here, 3 times 2 would give me a total of 6. Oops, forgot to change my inventory. All right, so this would be your final balanced equation for the aluminum oxide decomposition reaction. All right, so we'll walk through the other ones. Potassium bromide, so I'm gonna change my color. Again, when it's a compound, you have to look at the charges. So potassium has a +1 charge, bromide has a -1 charge. So potassium bromide is KBr. And then your arrow, potassium by itself is not diatomic, so it's just K. Bromine, however, is diatomic. So bromine, when it's by itself, has to have a 2. So this is your skeleton equation. This tells you what you have, it just doesn't tell you how much of everything you need. So now we're going to go back and add those coefficients. So again, you can write down your atom inventory on the side, but you don't have to. If I look on the product side, I can tell that I have 2 bromine atoms as a product. So I need 2 atoms of bromine on the reactant side. That 2 applies to the potassium as well. So now I need to go and add a 2 to the product side for potassium to make each of those atoms equal. So this would be your final balanced equation for that second example. All right, the third one, magnesium chloride. Again, since it's a compound, we have to look at the charges. So magnesium is +2, chloride is -1. So when you write your formula, you'll need 1 magnesium and 2 chlorides. And then one of your products is magnesium. so magnesium is not diatomic, so it's just Mg. Chlorine is down here in this list of diatomics, so when chlorine is by itself, you definitely need a 2. All right, so once you have your skeleton equation written, then you have to go back and check the number of atoms on each side to make sure they're equal. So if you look at this equation, we have Mg and Cl. On the reactant side, we have 1 magnesium, 2 chlorides. On the product side, we have 1 magnesium and 2 chlorides. So it's good. So this balanced equation would just have coefficients of 1. So hopefully that helped.